Okay, greetings once again and welcome to another awesome SETMind edition. In this edition, we're going to be looking at a very interesting calculus, to be specific, integration problem. This is from Harvard University for a course that is called Math 1A. And this problem is very interesting because you have sine of a log function, or sine which is a function of a logarithmic function divided by x dx. So let's go ahead and deal with this problem and hopefully you will understand the solution. But before we get into the solution, there's a couple of things that I need you to remember. And what I need you to remember is around logarithmic functions. So if you remember, whenever you are given log of x like this, all what that means is our log is to base 10, okay? That is what it means. However, we also know a couple of properties which are going to be useful here, of which one of them is that whenever you have log of x with base b, this can be written as log, let's say with base c of x divided by another log with base c, but we can put in b. This is very important for us to remember, and you will see why we need to remember that in our train of thought. Another important property that I need you to remember of these logarithmic functions is that whenever you have log with base e, this just becomes ln of x. They also refer to it as natural log. What else do I need you to remember? And it's very odd, but you needed to remember these fundamentals for you to be able to get done the problem. So what I also want to remind you is that the derivative of log of, let's say, for example, g of x, this is not so easy to compute, you know. So it is not so easy at first shot. But if I give you the derivative of ln of g of x, you should easily be able to see that this will be 1 over g of x and then multiplied by, according to chain rule, the derivative of g of x. So with all of these, now we can go ahead and try and simplify our problem. And for our problem, my first attempt is going to be at removing the log inside the sine. And how I'm going to do that is I'm going to use U-Substitution. With our U-Substitution, we are going to let u to be equal to log of x. And now, because I'm letting u to be log of x, it means we need to eventually remove the x and write it somehow in terms of u. And how we are going to do that is we are going to first write u in terms of ln, because we know how to derive a ln of any function. This one we can, but we need to do some manipulation. So I'm going to attempt to have base e on the log, because once I have base e, it means I can take whatever which I have and write it as ln. Okay? How I'm going to do that is, remember that what we have is log with base 10. And this, we said that you can write it as log of any common base. So if I want to convert this to log with base e, I'll need to put that, then put the 10 here. Okay? So this means what I have essentially is just ln of x divided by ln of 10. So now this is a bit easier to work with, because what you have is just ln of x divided by ln of 10. And as you can clearly see, our denominator, we are very happy because it's a constant. So meaning doing our differentiation should be easy. So we are not going to go and calculate that constant, because for the most part, you are not allowed to use a calculator. So let's go ahead now and find our du dx, derive u with respect to x. So if you look carefully, our ln of 10 will behave more like a constant, and what we are differentiating is just ln of x, of which the answer here will just end up being 1 over our ln of 10 multiplied by 1 over x. Okay, and if you observe carefully, you can now set your du or make it to be the subject. So if you observe carefully, you'll have du equaling, it will be 1 over ln of 10 times 1 over x and then dx. And how I usually think of these problems is, if you look at our problem carefully, we do have a division by x and we do have dx. So if you observe carefully, you can actually multiply both sides by ln of 10, such that what you are going to have is you are going to have 1 over x dx, of which that would account for this entire term, meaning we can now replace it with whatever which is on the left hand side. And just to make sure that we do not, fight over this is just, a typical thing that engineers, as you know them, would do. Okay, so we'll come at it from that angle. Very wrong from a pure mathematics perspective, but engineers get away with doing those things. So if you observe carefully, we'll end up having ln of 10 du equaling 1 over x dx. Now when we go back to our problem, we can just write it this way. If you observe carefully, you have sine of log of x, and we have 1 over x, and then we have dx here. So if you observe carefully, what we are going to do is to take all of that and equate it to that. Okay, but what we also see, or what we know, is that this log here is the same as our u. So this means now our problem is just purely in terms of u. So we now have sine of u and then multiplied by ln of 10 du, of which that ln we can pull out. So we'll have ln of 10 and then we are integrating sine of u du. By now you should know that in order for you to get sine, you must have differentiated negative cos. So this means our problem will be negative ln of 10 and then cos of u plus c, of which we can now plug in the u, which is just that log which we had. So let's go ahead and write our final answer. So our final answer is that integral there, remember what u is. So that integral sine of log of x divided by x dx is just simply negative ln of 10 and then cos of log x plus a constant, call it c. So what we have here finally is our answer. So for that problem, which is on our left hand side, top left, this is the solution which we're expected to find. And it really required you to be able to understand the basics, how your logarithmic functions work, your U-substitution, and doing a bit of some manipulation there and there. I hope this does make sense and it answers this question. And the question is, was this hard or was this easy? I'll leave that for you to decide. Cheers. Take care.